Well, I'd like to hear a new argument for the flat Earth, or at least a valid one. Do you have a sound and valid argument for the flat Earth?
Yeah, you've heard them several times. You've been
Just
in this
one.
community
Just one.
forever,
Oh,
so
none
I
of
mean,
them. Not no arguments for the flat Earth are sound.
so what is the point of even talking to you right now? Like, what am I going to accomplish by talking to you? You heard every single argument for the flat Earth, and you've rejected it. So, well, what are
But
we going to accomplish by having
well,
this
we would
conversation?
accomplish is that you would understand why I reject your arguments.
I already understand that.
You understand why I reject your arguments?
Yeah, I do.
Why is that?
Because they don't conform to your belief system.
No, that's not why. You're
So
mistaken.
what is it then? Well, what is it then?
They are logically invalid and unsound.
Okay, could you give me an example of one of those that are logically
Yes,
invalid and
yes,
unsound?
yes. The black swan argument is not a valid argument.
How so?
It commits the fallacy of equivocation.
Okay, could you elaborate that further?
Yeah, it equivocates between apparent and geometric horizon.
Those are two different things, though. Their
Exactly,
parent.
exactly. And the black swan argument, as presented by Quantum Eraser and Nathan Oakley, equivocates between two different meanings of the word horizon. It treats them as the same when they are, in fact, two different things. That's what equivocation means. And when you do that in a modus tollens or a modus ponens argument, you're committing a logical fallacy.
I'm going to have to disagree with you on that because the Black Swan argument treats the horizons as different because there are two horizons that are discussed
Uh,
in,
no,
in that argument, which is
no,
the
it doesn't.
geometric horizon and the apparent horizon. Those are two different horizons.
Yes, but the logic of the argument treats them as identical, and they're not identical.
No, no, it doesn't. No, it doesn't.
Yeah, it does.
Either way, we've been led to a place where we now know that when we look at the horizon, we're not seeing the geometry of Earth. So when you say, "Look, something's going behind Earth curve," we know that's not happening because we're not seeing the geometry of Earth.
Yeah, that doesn't
No,
follow.
Exactly.
and
That
let me
doesn't
and hey,
follow. That's a
and
non
also
sequitur.
and also can I say this is
What?
why the reason it's equivocating is because it says every horizon, meaning that it's putting geometric and apparent together. It's saying every horizon,
I'm
Yes,
sorry.
and then
yes,
proceeds to use just geometry to
yes,
define it, which is
yes.
about
Did
crazy.
you guys hear
So,
what I just said?
so it
Did you,
is
wait, are
not.
you guys
The, the,
hand waving?
apparent,
Just a
the
minute.
apparent horizon
Just
is
a minute.
not the geometric
So
horizon.
it is not a claim of the geometric of the globe model that an apparent horizon cannot be behind the geometric horizon. That is not a claim of the globe model.
Your claim is, though, that every time we see a boat disappearing bottom up, we're seeing the geometry of Earth. That's Earth curve to you, right?
But we're seeing
That is the
obstruction.
claim,
We're
yeah.
seeing obstruction. Yes.
Due to Earth curve, the
Yes.
geometry of
Due to
Earth.
Earth's
Yes.
geometry.
Yes.
Yes, but when we look at the horizon, we're not seeing Earth's geometry, right? Correct?
The apparent and the geometric horizon exist in relationship to each other, depending
Oh boy.
on the amount of refraction. The geometric horizon is the horizon you would see if there was no refraction. The apparent horizon is the horizon we see due to refraction. They exist in relationship to one another.
Do you guys call this obfuscation?
No,
It is
this
What's the word for
obfuscation.
what?
No.
The point
What's
of the
the
Black
word?
Swan is that the geometric horizon does not exist. It's based on geometry.
No,
We
it
never see
absolutely
it
does
because it
exist.
doesn't exist.
No, it
You
absolutely
lost
does
all your
exist.
geometry. You
No,
lost all your
no,
geometry.
the geometric
basically.
horizon exists on every spherical object.
It doesn't exist. If it did, we would see it.
That's also a non sequitur. The fact that you can't see
Says
it
who?
doesn't
Yeah,
imply it doesn't exist.
yeah. Hold up. Says who?
Says logic.
No, I'm talking to
Yeah,
you. Said
exactly. Says
said
logic. If we can't
no,
see
no,
it,
no,
then it doesn't
no. Hold up.
exist.
Yeah,
No,
that's
you
false.
just said if
That's
we
a non
don't see.
sequitur.
Okay, do you have any examples of where we see the geometric horizon of Earth?
Yeah, under conditions where the apparent and geometric horizons are nearly on top of each other.
Yeah, nearly. We never see the geometric horizon ever.
Well, we can see it, we just don't know where it is.
No, we can't see it. We
Sure you
never
can.
see it.
When you see a reflection in a mirror, you know that the object is there, whether it's being bounced back at you from another direction or not. So there is a geometric position of that object.
Right, right. But we know that the object is there because it exists in three-dimensional space. The geometric horizon can only be derived from a refracted horizon, so
No,
it's
no.
implied. We
No,
don't
it's-
know if it actually exists.
It's the other way
implied.
around. It's the other way around. The refracted horizon is derived from the geometric horizon. The refracted
No, the
horizon.
geometric horizon is derived from the refracted
No,
horizon.
that's false. The apparent horizon is a function of refraction due to the atmosphere. Atmospheric.
Can you show the math? Can you show the
That's-
math
that's
of
in-
how
in-
that works?
That's in Andrew Young's website on Green Flashes. He explains it. And there's a good picture by Roger MC that explains it right now. Remember, the geometric horizon is the horizon we would see if there were no refraction. But there is always refraction on a planet with an atmosphere. And so we don't really see the geometric horizon. We see an apparent horizon. But they exist in relationship to each other. The relationship is the lapse rate, the amount of refraction due to the atmosphere.
So, in other words, you're saying when we look at the horizon, we're not seeing the curve, the geometry of Earth. Is that what you're saying?
There's another interesting thing that you
Brenda.
can do. There's no response from Brenda right now.
I didn't quite catch what he was saying. I was clicking on something else. Sorry. What
To sum up your words, and yeah, to sum up your words, basically, in essence, you're saying when we look at the horizon, we're not seeing the geometry of Earth.
You're seeing
Is that what you're saying?
You are seeing the geometry. You're seeing the apparent horizon, but the apparent horizon exists in relation to the geometric horizon, and that relation depends on the lapse rate. The lapse rate is the amount. The lapse rate is the amount of atmospheric refraction taking place. That's what the lapse rate
Okay,
is.
was this just a yes or no? It was really like a yes or no question.
Well, you got more than you bargained for, so you're welcome.
I didn't even get an answer. You hit me with some word
You got
salad.
an answer. You got an answer. We do
Word
see,
salad answer. All right.
No, it's not word salad.
I get some ranch.
You got an answer. The answer is yes. What we see is due to the geometry of the Earth. We see the apparent horizon in relation to the geometric horizon, and that relation depends on atmospheric refraction.
So, Jeremy, what is the geometric horizon?
In reality, it doesn't exist, but in your guys' world, it's in the math only. That's the only place you can ever see it.
No,
Is in
it's
the
in
math.
the geometry.
What does that mean? It's in the math. What do you mean?
Yeah,
That's
the
the only
geometry
place-
is math, Brenda.
That's the only place your geometric horizon exists.
What is it? You're not telling me what it is. What is the geometric horizon?
The place where Earth starts to curve. Earth
No,
curve. It's Earth
No.
curve.
no.
When the boats are being disappeared bottom up and all that Earth curves in the way, that's the geometry.
Not
That'd be the
where
geometry.
the Earth starts to curve. You can try again.
Well, are you talking about tangent lines, or I don't know where you want to go with this?
I want you to display a knowledge of the topic to engage in the conversation with. You're
All right,
sitting
so
here,
do you want to
you're
talk
drilling
about?
people from a position of ignorance. What is the geometric horizon?
You don't get salty because I just got fucked Brenda up just now.
You
Don't get
did
mad.
nothing of the sort, Jeremy. You're fucking yourself up. You're beating your chest because you don't know things. That's not
All
intelligent.
right.
What is the geometric horizon, Jeremy?
The geometric horizon would be the place you draw. I don't know what you're looking for, but it would be a place where you would draw a tangent line to. Like I don't know what you're looking for here. Why don't you just tell me where you want to go with this?
Looking for an understanding of
I would
what
describe. I would define it as Earth curve. That would be my personal definition of the
well,
geometric horizon. Would be Earth curve.
that would
Well,
be
that begins
silly.
at your
It's
feet.
not an effective way to communicate to other people what you
What's your
think.
definition of What's your definition of geometric horizon? I put it as Earth curve.
It's
The
the
geometry
location.
of the.
It's the location where the horizon would be. If we had no atmosphere, we arrive at this through mathematical means to determine the distance to it, where it would be, the last edge of the earth, so to speak, last bit of land or surface that you would be able to see where the earth appears to meet the sky. That's what the horizon is. The line where the earth appears to meet the sky. Okay, it's not the apparent line. It is the line. That's how it's defined. You read the definition. To define it as the line where the earth appears to meet the sky. And then people jumble that up. Now, anyway, that is simply a calculated distance based on the geometry of the sphere where this would occur were there no refraction. It can't get any simpler than that. Given
So
the
Earth
fact that
curve.
we have refraction, it is not effectively our horizon. We
Yeah, I
tend
would
to
have.
see the horizon a little farther away, sometimes more farther away. Very rarely, if ever, at that actual point, depending upon the precision you want to try to pin it down to. This is not exact. We're using an idealized sphere when we use the Earth curve calculator anyway, unless you go and adjust the radius for your location on the Earth. You're dealing with approximations to begin with, and this all becomes semantics and child's play.
I would have more simple.
To try to shit on us, but they shit on themselves.
Jeremy, can
I
I
would have
try?
more simply. Hold on, curve just went off for like 4.5 minutes. Let
Yeah,
me
that's
just
okay.
respond real
I'm
quick.
sorry.
Yes,
I would have
that's
just
good.
more. I would have just more simply defined that it as Earth curve. Would be a simpler way to state that, but
But
that
that's
is a more
false.
in-depth
But it's false.
explanation.
It's
What do you mean?
false.
It's the same thing you said. Just you just use a lot more
It,
words.
no, it's not. I did not say it's Earth curve.
No, I'm saying it's
That is
essentially the
that
same thing. It's basically the
mind-numbingly.
same.
No,
Go
it's
ahead.
not, Jeremy. And the fact that you don't understand that is frightening.
It's the place where we would. Oh my God. You said the same thing I did, so I
No,
don't
you
know.
were just getting ready to say something different,
Yes, he was. So
and you
it's
stopped
You said it's
yourself.
you said
Why?
it's where we would see. You said it's where we would see the Earth drop or curve or whatever if there was no atmosphere. The geometric.
Ah,
he
no, 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 no,
he,
no. Not where it drops, not where it curves. I said it would be that would be the distance to,
The
like the
line where
last bit of land on an idealized sphere,
the last bit of land we would be able to see on a sphere.
where
The
the Earth would appear to meet the sky. Yeah,
that would I would just say that's the Earth curve right there. You're seeing the geometrical property of this sphere,
well, it,
the
in
curve
a
of it.
sense, okay,
If you're
that's
looking at a
not horrible.
basketball, I mean, if you're looking at a basketball, you could just describe the same thing you said. You could just say that's the basketball curve.
yeah. Well, it's the horizon
That's
of the
what. That's how you
basketball.
would describe. That's how you would describe it. And if you were
Right.
looking at a basketball, you'd say that's the
To
curve of the
who?
basketball.
To who? Your 2-year-old?
Yeah, whoever, an adult, another adult, I would say there's the basketball curve. Look, see. There's the line of the curve.
That's sad.
Jeremy,
What?
let me try something, Jeremy. Uh, you can't see the opposite side of that basketball, can you?
No.
And the reason why is because the basketball itself gets in the way and blocks you from being able to see it, right? So the geometric curve is the line that that line where the earth gets in the way of itself, just like the basketball gets in the way of itself and prevents you from seeing the other side of the basketball, right? So it's obstruction, correct? That's what the geometric curve is. It's obstruction.
Well, you say it's obstruction. I say it's an optical effect, just like everything
Well,
we're seeing out
sure,
there is
it's
just
an
an optical effect.
yeah, it's an optical.
The ground ramping up, the sky ramping down, all kinds of optical effects
Well,
happening out there.
with the basketball obstructs your vision from seeing the opposite side of the basketball. That's also obstruction. And that's it's geometric horizon if you want to describe it that way, correct? You understand?
The basketball, let's call it basketball curve, would be
Sure,
hiding the
sure.
line. We can call it the line that's separating the sky from the basketball, whatever you want to call it.
Yes, the basketball's
The geometric,
geometric horizon
that's
of
fine.
the basketball, right, is the point at which the basketball itself obstructs your vision of the far side of the basketball. It's obstruction.
God damn.
Right.
It's obstruction due to curvature.
You say this is where we come to difference, because I'm saying we don't see the geometric horizon, and I'm saying it's an optical effect.
Well, on a basketball, we do see the geometric horizon.
On a basketball, yes.
Yeah. Well, I mean, I
On
suppose.
Earth,
I
we,
suppose
we don't see the
technically.
geometric horizon on Earth.
Yeah, because of refraction, because the Earth has an atmosphere. Basketballs don't have an atmosphere. Right. So the geometric horizon of the basketball is obstruction due to curvature, and the geometric horizon on the Earth is obstruction because the Earth gets in the way of you seeing the far side of the Earth. However, we don't see that geometric horizon. What we see is the apparent horizon, and that's simply due to refraction. But that's not a big deal because we can know how much refraction is taking place on a particular day, due to the atmospheric conditions. We can know the lapse rate of that day due to we can calculate that, and we can figure out how far away the apparent horizon is from the geometric horizon. We can account for that. It's standard refraction, typically. But in the black swan fallacy image, that particular day, the refraction was exceptionally high. Okay? Glad we're clear on that. Thank you.